The instance statements are statements that specify all the component-related information in a netlist. To completely specify a single component within a circuit netlist, you must provide the following information, like a unique component name for the component, the names of nodes that the component is connected to through node numbers or textual description, then master name of the component that identifies the type of component, and the parameter values associated with the component in a Spectre instance statement. The master can be a built-in primitive, capacitor, resistor, inductor, etc. model, a subcircuit, or an AHDL, Verilog A module. However, each instance statement needs a unique name. This example shows you an instance statement for an output capacitor C0 placed between net 13 and GND. Also note that it has a cap value assigned to it. Instantiating subcircuits in the top-level netlist. The top-level netlist contains the circuit description with calls to primitive devices, subcircuits, and other devices. Included in this section are instantiations of devices and subcircuit calls. In this example, there are instantiations of 3-voltage devices, along with a call to the subcircuit my_mos. Using the tRise or dtemp parameter. To an instance statement, you can specify the temperature rise parameter as a subcircuit or a primitive parameter. For a Spectre syntax, we use tRise, and for Spice syntax, we use dtemp. This parameter has an accumulated effect for the subcircuit. In this case, we have the simulation temperature set to 27 using the temperature parameter in the options statement. Here, for the X1 load output instance, we have tries set to 43, while for XX1 RC sub it is set to 5. Now, because of the accumulating effect, the effective temperature of the X1 load output instance is 70, and for XX1 RC sub it is 75. So you can confirm that this parameter has an accumulated effect for the subcircuit, and these two parameters are aliases. Similar to the temperature rise parameter, you can specify the temperature temp parameter as a subcircuit or a primitive parameter in an instance statement. The temp parameter overwrites all the other temperature values set in the options or tries parameter, and the subcircuit will be simulated at that temp value. In fact, it has an exclusive effective temperature effect for that specified subcircuit. So here in this example, we have the simulation temperature set to 27. Then, for the X1 load output instance, we have a temp set to 43, while for XX1 RC sub it is 5. Now, because of exclusive temperature effect, the effective temperature of the X1 load output instance is 43, and for XX1 RC sub it is 5. So, you say that device of temp in the subcircuit instance parameter will only simulate at the temp value set on it. This slide example has a combination of both tRise and temp parameters defined in a sub-circuit instance statement. For this case, we have the simulation temperature set to 27. Then, for the X1 load output instance, we have a temp set to 100. And for XX1 RC sub tRise is set to 50. Here, the effective temperature of the X1 load output instance is 100, as temp has exclusive temperature effect. And for XX1 RC sub it is 150, where tRise has accumulating effect. So, you say that device of temp in the subcircuit instance parameter will only simulate at temp, while tRise has an accumulated effect.
In Spectre, we have the temperature rise parameter, tRise, that rises the temperature value of the subcircuit from ambient. The tRise parameter can be specified as a subcircuit parameter or a primitive parameter. However, in Spice, the differential temperature parameter, dtemp, is used for temperature rise. Here, I have a simple load output netlist file with the subcircuit definitions. In the netlist, you have the option statement that sets the temperature to 27. Then you have two subcircuit definitions, RC sub and load output. The RC sub subcircuit is instantiated inside the load output subcircuit with the instance name XX1, while the load output subcircuit is instantiated with the instance name X1. Also, at the end of the file, you have the simulator options. the transient analysis statement, and then the info statement to display all the parameters information into the log file. Now run a Spectre simulation on this Netlist file from the command line. Notice that all the parameter values are written to the log file. So open the log file using the text editor. In the log file, you have the temperature parameters printed at the end of this simulation because of the info statement. Here, both the subcircuits, load output and RC, has an effective temperature value of 27 degrees. Now move to the Spectre netlist and add the T-rise parameter to identify its effects. So to the instance statement, add a T-rise value of 43 for the load output subcircuit and add a T-rise value of 5 degrees to the RC subcircuit instance. Save this netlist and in the command line rerun the simulation. Now move to the log file and reload its results. In the log file, you can notice that the effective temperature value of the load output subcircuit is 70, while the effective temperature value of the RC subcircuit is 75. This is because the T-rise parameter has an accumulated effect for the subcircuit. Now move to the netlist file once again and change the T-rise parameter to temp. Save this netlist file, rerun the simulation and see what happens. Move to the log file and reload its results. Here in the log file, you can notice that the effective temperature value of the load output subcircuit is 43, while for the RC subcircuit is 5. This is because the temp parameter has an exclusive effective temperature for a specified subcircuit. Now move to the netlist file once again. Let's change one of the parameter to T-rise and other parameter to have the temp value and see what happens. Say for the load output, have a T-rise parameter, while for the RC sub, have a temp parameter. Rerun this simulation and move to the log file. With this setting, it changes the effective temperature value to 70, while for the RC sub it is 5. This is because the temp parameter overrides the temperature value set by the T-rise parameter. So the T-rise parameter rises the temperature from ambient, while the temp parameter has an exclusive effective temperature for a specified subcircuit. Thanks for watching this video.